Okay, so I'm standing at the sink washing my hands, and this thought hits me. How does soap actually know where the germs are? Like, I rub this slippery stuff on my hands for 20 seconds, rinse it off, and somehow all the bacteria and viruses are just gone. The soap went straight to the germs and took them out like some kind of microscopic hitman. But here's what's wild. I'm also covered in skin cells, oils, and all kinds of other stuff, and the soap leaves most of that alone. So how does it specifically target the bad guys? Seems suspiciously like soap has a personal vendetta against germs. But fear not, it's only science. So how does soap actually find and destroy germs, and why is it so good at its job? But before we dive into this cleanup mission, if you want more mind-blowing science about everyday things, hit that subscribe button right now. Trust me, your hands will thank you later. Here's the thing that's going to flip your understanding. Soap doesn't actually know where germs are. It doesn't seek them out or target them specifically. In fact, soap doesn't even kill most germs. I know, plot twist. What soap actually does is way more clever and brutal than that. It rips them apart and washes them away. Let me explain. To understand how soap works, we need to talk about what soap actually is. A soap molecule is this weird little thing with two completely opposite ends. One end is hydrophilic, which means it loves water. The other end is hydrophobic, which means it hates water but loves oil and fat. So every soap molecule is basically a tiny split personality chemical with one end desperately trying to get away from water and the other end clinging to it. Now let's talk about germs for a second. Bacteria and viruses aren't just floating around as naked little organisms. Many of them, especially viruses like the flu or COVID, have an outer layer made of lipids, basically a fatty membrane that holds the whole thing together. This lipid layer is their protective shell, their armor. Without it, they fall apart and become harmless. Here's where soap becomes a demolition expert. When you wet your hands and add soap, those split personality soap molecules get to work. The water-loving ends point toward the water, and the fat-loving ends start searching for anything oily or fatty to grab onto. And guess what's fatty? That protective lipid membrane on viruses and the outer layer of bacteria. When a soap molecule finds a germ, its hydrophobic tail jams itself right into that fatty membrane, like a crowbar. But it's not just one molecule, it's thousands of them. They all start wedging themselves into the lipid layer from every angle. And because the other end of each soap molecule is being pulled toward water, these molecules create this incredible tension. They're literally being pulled in two directions at once. And then the membrane just rips apart. The soap molecules tear open the protective shell and the germs inside spill out. The virus or bacteria is now destroyed, broken into pieces, completely neutralized. But soap doesn't stop there. Those soap molecules then wrap around the germ fragments, forming tiny spheres called micelles. The hydrophobic tails point inward, holding on to the oily germ pieces, while the hydrophilic heads point outward toward the water. These micelles are like tiny cages, trapping the germ debris. When you rinse your hands, the water washes away all these micelles along with the destroyed germs inside them. Down the drain they go. Soap doesn't kill germs like an antibiotic would. It physically destroys them and removes them from your skin. That's why washing with soap and water is more effective in many situations. You're not just killing germs, you're literally removing them from your body. But wait, if soap is so aggressive with fatty membranes, why doesn't it destroy your skin cells too? Great question. Your skin cells do have membranes, and soap can interact with them, but your skin has multiple layers of dead cells on the surface that act as a protective barrier. These dead cells are constantly being replaced, so even if soap disrupts some of them, it's not a big deal. Plus, you're only washing for 20 seconds, not long enough to cause serious damage to living cells underneath. However, this is why washing your hands too much or too aggressively can dry out your skin. Soap is also removing the natural oils your skin produces, and those oils help keep your skin moisturized and protected. That's the trade-off. Soap is incredibly effective at removing germs, but it's not particularly gentle on your skin's natural defenses. Now, here's something interesting. Soap works on dirt and grease the same way it works on germs. That's why soap is so good at cleaning dishes and getting stains out of clothes. Anything fatty or oily gets surrounded by soap molecules, trapped in micelles, and washed away. Soap doesn't discriminate. It's just really good at grabbing onto fats and oils. But here's the kicker. This whole process only works if you actually scrub and rinse properly. Just putting soap on your hands and immediately rinsing doesn't give the soap molecules enough time to break apart germ membranes and form micelles. That's why health experts tell you to wash for at least 20 seconds. You need time for the mechanical action of rubbing to spread soap everywhere, and for the chemical action to destroy and trap germs. And the scrubbing part is crucial. The physical friction helps dislodge germs from the tiny crevices in your skin and helps soap molecules make contact with more surface area. Soap plus scrubbing plus time equals maximum germ destruction. So soap doesn't know where germs are. It doesn't need to. It just indiscriminately attacks anything fatty. And since germs conveniently have fatty membranes, they get absolutely demolished in the process. It's less like a targeted missile and more like a demolition crew that destroys everything oily in its path. Anyway, understanding how soap commits germ genocide on your hands is going to cost you around 1 subscribe, and I'll just flip the screen here real quick for you.